and we're going to work on intensity. Intensity. So what exactly is it? Well, it's measured as the units of watts per meter squared, and it comes from power, which is measured in watts, and area, which is measured in meters squared. So intensity is something that's very intense. So for example, let's say this gong is hit, and if you're very close to it, it's going to be a lot louder than if you were further away from it. Now, imagine yourself in this position, and this area right here, this depends on the radius, and you can see this from the equation. So intensity is watts over area. So the area does matter. So now we're going to go to what is exactly A. Well, intensity is measured in radius because we of a sphere because it can it's all around us kind of thing. And so if you're further and further away from it, uh, it's going to be a lot less intense. So what we get is this equation where sound measured in decibels versus distance. So sound is proportional to the area of the radius, sorry, which is distance m. So the area is 4 pi r squared. So, example. An example of baby crying. Imagine yourself, you're really close to the baby. It's going to get bigger and bigger and bigger. Well, it's going to be a lot more intense. So think about it. If the numerator is a lot bigger, because of the smaller area, there's going to be a larger intensity. Whereas if the denominator is larger, area is bigger, there's going to be a lower intensity. This can be really helpful when you're solving problems to think about it conceptually if your answer makes sense. Oftentimes in physics, it's not the process itself, it's a conceptually understanding of what is exactly happening. So, I max and min. Now I made this I max and min because the maximum sound our ears can hear is I equals 1000 watts per meter squared. Now that's if your ears are going to bleed, that's really loud. And I naught is the smallest sound humans can hear, which is 10 to the negative 12. Now many of you, on even our repeating, may have gotten wrong saying you click 0. No, it's not really 0. If you're in a cold, not say cold room, but a really quiet room, there's still a little sound, and that's 10 to the negative 12. Well, we can measure this with decibels being 10 times the log of intensity over intensity naught, which is the initial, and it's deci because we multiply by 10, right? So decibels is we multiply by 10. That's where it gets the name from. And if you can rearrange this, I rearranged it for you. Intensity is also 10 to the power of decibels divided by 10 multiplied by the intensity initial. So an example problem. So what I've done is I've given two problems for you guys. Problem 1 and problem 2. Problem 1's a bit trickier than problem 2. You may have to read it carefully. And I want you to pause this and then try the problem itself and go to the next slide, which I'll put up in a bit, and see what you can do, and feel free to go back and pause for the formulas or figure out the concept. Your answer should make sense to the concept. So think about the question and try to draw it out. It really helps out. And here are the answers to the question. So don't look at this and just study off this. Go to the back page, and here we are back here, and that's all. So best of luck solving these two problems. That's it for now. Thanks.